Hi again, we're back talking about the cutpoint command when doing histograms in Minitab. As I said, for our projects in Minitab, we're going to want whole numbers for our lower class limits, our cut points. Sometimes if you do Minitab and you do the default, it takes a little bit to get those cut points. So sometimes it's good, it will be very useful to know how to use the cutpoint command. So if you're looking here, look at our commands for a histogram. You know, we say histogram C1, that means our data must be in C1, and then the very good title of distribution of, and in our case we're doing the Altria stock example, so we say distribution of, and our variable is the volume of Altria group stock for 35 trading days. Our label for the horizontal axis is volume of Altria group stock. Again, that's our variable, and it tells us the units it's in millions. And then that very last command, the cut point command. And what are those numbers, 3, 11, and 1? Well, we're going to talk about that because look what it is. For that sub-command, the cut point, 3 was the minimum value of the data, 11 was the maximum value, and 1 was the class width. And we need to determine these numbers. Now from our data set, we don't necessarily have to take in our data set the minimum. We can, as with our histogram, make a reasonable lower limit, a reasonable min, and a reasonable max. So let's look at our example for the Altria stock example. If you use what's called the describe command like I showed you in the last video series, we could find the minimum of that data for the Altria stock was 3.01 and the max was 10.96. Reasonable lower limit would be 3. If I have a lower limit of 3, it will enclose the smallest data point in that set, which was 3.01. Having a maximum value of 11 will include the largest data value in that data set, which was 10.96. So you want to make sure the minimum and maximum, the range that you create, contains all the data values. Be very careful about that. But now I have whole numbers for my min and max, and in fact I picked a nice range there because you have 3 and 11, and my range would be 11.3. 11 minus 3, excuse me. So, if we want whole numbers for our lower class limits, then the number of classes must be a factor of the range we just calculated. So any of the factors of 8 are possible values for the number of classes we can have. But remember our guideline, we like to have between 5 and 20 classes. Less than 5, remember what we said, everything gets too bunched up, and anything more than 20, everything's too spread out, so we can't see trends or some type of trend in the data. So let's look at the factors of 8. 1, 2, 4, and 8. In other words, all the numbers that could go into 8. Well, 1 and 2, and 4, all three of those numbers are too small for the number of classes. So we have only one choice. We have to have 8 classes if we want our endpoints, our lower class limits, to be whole numbers. So we're going to say we want to have 8 classes. Now, remember what we need. We have the min and the max, and we have that. The minimum value we said was 3. The maximum was 11. And now we have to find the class width. Well, the way you find class width is you have the range and the number of classes. So we have the range and the number of classes, and that will give us our class width. So the class width for the Altria group example would be the range of 8 divided by 8 classes. So we're going to have a class width of 1. So the cut point command is going to be 3, the minimum value that we made, 11, reasonable upper maximum value, and the width we just found out to be 1. And that's why we have that in there. So now let's take a look at another example. Oops, here we go. Sorry about that. So, let's say that when you did your describe command, you found the data value to be, the minimum data value to be 20.3 and the maximum data value to be 59. I want you guys to determine a cut point command. So, I'll go on, but you might want to stop the tape and really try this out. So, here's just one of the many ways you could do this problem. Now, I didn't take the most obvious way here, so I did a little bit different. I took a minimum value of 15 and a maximum value of 65, which gave me a range of 50. So I look at the factors of 50, 1, 2, 5, 10, 25, 50. So 5 and 10 are the classes that are our best option for the number of classes. Remember, we have to have classes between 5 and 20. So let's say that I choose to have 5 classes. That way I can figure out the width. The width would be my range, which was 50, divided by how many classes I want, which was 5. So my class width is 10. So I now have my cut point command, which would be cut point, my minimum value of 16, colon, my maximum value of 65, slash 10. And really we should end it with a period because usually that's the last command in there. It really doesn't matter, but we'll have that. So that would mean that my data starts at 15. That's my lower class limit. My very first class goes from 15. The next class would begin with 10 more than that, would begin with 25. The next one would be 35, 45, 55 until I get 65, and that makes out the even 5 classes that we want. So let's say now, which most of you probably picked, 20 and 60 as your minimum and maximum. That would give you a range of 40. So my possible classes are factors of 40, and there's lots of factors of 40, 1, 2, 4, 5, 8, 20, and 40. So our best option would be 5 and 8, and maybe even 20. So we actually have 3 options. So let's say we pick 8 classes. Then our class width would be 5 because our range is 40 divided by the number of classes I chose, which was 8. So that gave me a class width of 5. So my cut point command would be cut point, my minimum value of 20, my maximum of 60, and with a class width of 5, and there should be a period behind there or a semicolon depending on where it is in the subcommands. So your graph would begin, the lowest lower class limit would be 20, the next one would be 25, the next one would be 30, 35, 45, 45, 55, and it ends with 60. So I hope that helps you to do the cut point commands.